Hello, friends. History doesn't only remember kings, wars, and empires. It also remembers the great minds who changed how humanity understands the world itself. Tonight, in the second episode of our People Who Changed the World series, we welcome one of the most recognized names in human history. When you hear his name, a single word comes to mind: genius. Albert Einstein. Today, the very word Einstein has become a synonym for intelligence. But what made him so extraordinary? Was it his sharp mind, his relentless determination, or the groundbreaking theories that redefined science? In truth, it was all of these. Einstein sought to uncover the secrets of the universe not only through mathematics, but through the power of imagination. He saw the flaws in Newtonian physics and replaced them with his theories of special and general relativity, forever changing our understanding of space, time, and gravity. His explanation of the photoelectric effect even won him the Nobel Prize in physics. But every legend has a beginning. Let's start his story at the very start. Albert Einstein was born on March 14, 1879, in the city of Ulm, in the German Empire. When he entered the world, his mother was taken aback. The shape of his head was unusual, and his skull seemed oversized. The doctor assured her that newborns could appear this way and that it would normalize over time. And indeed, within weeks, it did, though a slight elongation remained for life. Of course, it wasn't the shape of his head that set him apart. It was the way his mind worked. Yet, as a toddler, he caused concern. He spoke late, far later than other children, making his family wonder if something was wrong. When Albert was 2.5, his sister Maya was born. Their mother, a passionate lover of music, arranged lessons for both children from an early age. Albert began learning the violin at 6 and continued until the age of 13. His love for music never faded. It was a constant source of joy for the rest of his life. Einstein's defining trait was curiosity, deep, relentless curiosity. At age 5, his father showed him a simple magnetic compass. Young Albert was fascinated that the needle pointed north without being physically touched. He later recalled, "That experience left a deep and lasting impression on me. There had to be something hidden behind what we see." That small moment was his first scientific spark, one that would, decades later, connect to his work in electromagnetism. In his early teens, a family friend, a poor Jewish student from Russia, introduced him to popular science books. Every Thursday over lunch, they would spend hours talking about physics, mathematics, and philosophy. It was during these conversations that the young Einstein's exceptional intellect began to reveal itself. At 11, he began religious studies at home, following Jewish traditions with devotion despite his parents' lack of religious interest. But the more he read about science, the more he noticed contradictions with sacred texts. Slowly, he became a skeptic. Later, his idea of God aligned closely with the views of Baruch Spinoza, a God that was not a person, but the harmonious laws of nature itself. One of the most influential figures in his early life was his uncle, who nurtured his love for mathematics. At age 12, Albert stumbled upon a small geometry textbook. The clarity and precision of its proofs astonished him. "This certainty left an indelible impression on my mind," he said years later. After primary school, he attended the Luitpold Gymnasium, a strict Catholic school in Munich. The militaristic discipline was suffocating to him. He gave his teachers nicknames like Sergeant and Lieutenant, and disliked the rigid, memorization-heavy approach. At 16, Einstein applied to the Swiss Federal Polytechnic in Zurich. He excelled in math and physics but failed in other subjects, forcing him to spend another year at a nearby high school. That year turned out to be, in his own words, the happiest of my life. The school encouraged independent thinking, something Albert thrived on. By 1896, he was admitted to the Polytechnic and began a 4-year program to become a mathematics and physics teacher. His professors included the great mathematician Hermann Minkowski. Outside the classroom, He spent countless evenings in cafes with friends, discussing science, literature, and philosophy. During this time, he met Mileva Marić, the only woman in his class. She was brilliant and equally passionate about physics. The two became inseparable study partners and later a couple, despite disapproval from Albert's mother, who disliked Mileva's age, background, and religion. In 1903, they married. Einstein graduated in 1900, hoping for an academic post. But his professors, unimpressed by his independent and often rebellious approach, offered no recommendations. For 2 years, he searched unsuccessfully for work until a friend's father helped him secure a job as a technical assistant at the Swiss Patent Office in Bern. The work was not glamorous, but it was steady, and more importantly, it gave him time. Time to think. Time to imagine. And in that quiet office, science was about to change forever. The year 1905 is now remembered in physics as Annus Mirabilis, the miracle year. While still working full-time at the patent office, Einstein published 4 revolutionary papers in the Annalen der Physik, each of which would shake the foundations of science. Special relativity. Until then, physicists believed time and space were absolute, the same for everyone. Einstein shattered this idea. He proved that time can slow down or speed up depending on relative motion, that space and time form a single continuum called spacetime, and that the speed of light is the same for all observers regardless of their motion. This meant simultaneity, 2 events happening at the same time, was an illusion, dependent on the observer's frame of reference. Mass-energy equivalence. From special relativity came the most famous equation in physics, E equals mc squared. This deceptively simple formula revealed that mass and energy are interchangeable. Mass can be converted into energy, and vice versa. This principle explained how stars shine and laid the groundwork for nuclear power, and unfortunately, nuclear weapons. Brownian motion. Scientists had long debated whether atoms truly existed. Einstein's analysis of the random motion of pollen grains in water provided mathematical proof of atomic reality. His formulas allowed the size of atoms and molecules to be calculated with remarkable precision. The photoelectric effect. Light, thought to be purely a wave, could also behave like particles, quanta of light later called photons. Einstein showed that when light struck a metal surface, it could eject electrons, and that the energy of these electrons depended not on the light's brightness, but its frequency. This work earned him the 1921 Nobel Prize and laid the foundations for quantum mechanics. To publish just one of these papers would have been a lifetime achievement. Einstein published all 4 in a single year. Newton's physics had ruled for over 2 centuries. In 1905, Einstein rewrote the rulebook. The miraculous year of 1905 had put Albert Einstein on the map of the physics world, but it was only the beginning. Special relativity had established the universe's speed limit, the speed of light, but it left a colossal question unanswered: gravity. According to Newton's theory, which had reigned for 200 years, gravity was a mysterious force that acted instantaneously between objects. This was in brutal contradiction with the rule Einstein had just established that nothing can travel faster than light. For Einstein, this was a revolution that had to be completed. Understanding what gravity was became an obsession for him. Of course, here is the full, detailed text translated into English, maintaining the structure and tone of the script. Part 1. The Theory of General Relativity and its Proof. The miraculous year of 1905 had put Albert Einstein on the map of the physics world, but it was only the beginning. Special relativity had established the universe's speed limit, the speed of light, but it left a colossal question unanswered: gravity. According to Newton's theory, which had reigned for 200 years, gravity was a mysterious force that acted instantaneously between objects. This was in brutal contradiction with the rule Einstein had just established that nothing can travel faster than light. For Einstein, this was a revolution that had to be completed. Understanding what gravity was became an obsession for him. The breakthrough moment for this obsession came in 1907 with what he called the happiest thought of my life. While sitting in the patent office in Bern, he pictured a simple scene in his mind. What would a man working on a roof feel if he were to fall? During his fall, if he dropped the tools he was holding, they would remain suspended in the air with him. For that moment, the man would not feel his own weight. He would experience a state of weightlessness, just like in space. Then he moved the experiment into an elevator. If an elevator's cables were to snap, the person inside and the elevator itself would fall to the ground at the same speed, and the person would feel weightless for a moment. At that instant, a brutal reality flashed in his mind like lightning. Experimentally, acceleration and gravity were indistinguishable from each other. This idea, which he named the equivalence principle, became the cornerstone of general relativity. This was the beginning of a painful 8-year intellectual journey. Now, the issue was to translate this idea into mathematics. Einstein knew that Euclidean geometry would be insufficient for this task. To describe the curved fabric of the universe, he needed more complex mathematical tools he had never used before. He struggled so much on this path, got lost in so many equations, that even his close friend and the father of quantum theory, Max Planck, warned him, saying, "Of course you can work on this subject, but you will not succeed. And even if you do, no one will believe you." But for Einstein, there was no turning back. Finally, he reached an incredible conclusion. Gravity was not a force. It was the result of massive objects, like the sun, bending the fabric of space-time, much like a bowling ball warps a stretched sheet. The planets orbited the sun not because they were pulled by a mysterious force, but because they were constantly trying to travel in a straight line through the massive curve the sun creates in space-time. In other words, they were simply rolling inside that depression. This theory perfectly explained even the small deviations in the orbit of the planet Mercury, which Newton could never account for. But theoretical genius needed concrete proof. Einstein knew there was only one way to prove his theory: a total solar eclipse. If he was right, a massive object like the sun should even bend the light from distant stars passing by it. All that was needed was for the sun's bright light to be blocked for a moment so that the positions of the stars behind it could be observed. In 1919, while the wounds of World War I were still fresh, a British astronomer named Arthur Eddington set out to test the theory of this German physicist. During the total solar eclipse of May 29, 1919, Eddington and his team confirmed that starlight was indeed bent by the sun, exactly as predicted by general relativity. Einstein was right. Suddenly, this little-known man was gracing the headlines of newspapers worldwide. People were aware that he had accomplished something monumental, but no one fully understood what it was. In fact, when a journalist once asked Eddington, "Professor, is it true that there are only 3 people in the world who understand relativity?" The witty British astrophysicist paused and replied, "I am trying to think who the third person is." Newton's 200-year empire had officially fallen that day. Behind this overwhelming scientific victory lay the brutal failures and tragedies of Albert Einstein's personal life. Mileva Marić, the brilliant and passionate physicist he met at the Zurich Polytechnic and the only woman in their class, was not just a wife to him, but an intellectual partner. They studied physics together, reviewed books, and debated for hours. However, Einstein's family vehemently opposed the relationship because Mileva was of Serbian descent and older than him. They married anyway, but this marriage was slowly poisoned in the shadow of Einstein's obsessive devotion to science. Mileva was the first and closest witness to Einstein's genius, but she was also its greatest victim. While Einstein's mind was occupied with the secrets of the universe, the order of the house, the children, and daily life fell on Mileva's shoulders. Mileva was jealous of her husband's relationships with other women and sank into a growing depression. The most ruthless depiction of this situation was this: Einstein would be writing his equations in a notebook with one hand while rocking his baby's cradle with the other. For him, physics came before everything, even his family. Eventually, the relationship failed. When he moved to Berlin with his family in 1914, His growing closeness with his cousin Elsa was the last straw. Mileva took their children and returned to Zurich. A few years later, during a visit to see his children, Einstein proposed divorce to Mileva, and they officially divorced in 1919, the very year of his general relativity triumph. This was a heavy price that genius paid and made others pay. Shortly after his divorce, Einstein married his cousin Elsa. Elsa was not an intellectual partner like Mileva. She was a protector who looked after Einstein, cared for his health, and created a suitable environment for him to work. She made Einstein's life easier. However, Einstein's growing fame and the intense attention he received from women caused problems in this second marriage as well. Still, Elsa remained with him until her death in America in 1936. The cold sentences Einstein wrote in his notebook after Elsa's death reveal the complexity of his personality. "I have adapted to life here in a short time. I live like a bear in my study. This separation has been intensified by the death of my female commander, who got along better with those around her than I did." For him, relationships always took a back seat to the grand equation of physics. The years of Einstein's peak fame were also the years Europe was descending into darkness. With the rise of the Nazi Party in Germany in 1933 and the rapid increase in antisemitism, life in his homeland became impossible for Einstein. His theories were labeled Jewish physics, and his life was in danger. For this reason, he had to leave Germany and settled in the United States, taking a position at the Institute for Advanced Study in Princeton. Here, Einstein, who had identified himself as an ardent anti-militarist and pacifist throughout his life, was forced to confront the most brutal irony and the most difficult decision of his life. News that scientists in Nazi Germany were trying to build an atomic bomb terrified the entire world, especially the scientific community. Einstein believed that a man like Hitler could only be stopped by brute force. Driven by this fear, he, along with a group of other scientists, wrote the famous letter to U.S. President Roosevelt. In the letter, they warned the president that the Germans might win the race to build an atomic bomb and that Hitler would not hesitate to use such a weapon. This letter, though not directly, became one of the most significant factors that spurred the U.S. to launch the Manhattan Project and accelerate the creation of the atomic bomb. At the end of the war, America's dropping of 2 atomic bombs on Japan and the horrific tragedy that ensued plunged Einstein into a deep regret that would haunt him for the rest of his life. Years later, crushed under the weight of this decision, he would utter these painful words: "Had I known that the Germans would not succeed in developing an atomic bomb, I would have done nothing." The man of peace had, albeit unwillingly, contributed to the birth of the world's most destructive weapon. In the post-war years, Einstein's scientific struggle shifted to a different front. He was deeply dissatisfied with the direction of quantum mechanics, a field whose foundations he had helped lay. The assertion of quantum theory that probability and uncertainty lay at the core of the universe was completely contrary to his deterministic view of the universe, where everything was governed by a cause-and-effect relationship. He was particularly skeptical of Heisenberg's uncertainty principle. In his famous debates with pioneers of quantum theory like Niels Bohr, he made his famous statement, "God does not play dice with the universe." But this time, Einstein, the one who started the revolution, seemed to be falling behind the new one. Faced with Bohr's coherent counterarguments, he was losing this intellectual battle. He had become a revolutionary who could not accept the new rules of the world he had helped create. Einstein spent the last 30 years of his life at Princeton in a nearly reclusive state, dedicated to one single grand goal, the unified field theory. He dreamed of uniting all the fundamental forces of the universe, gravity, electromagnetism, etc., into a single, elegant set of equations. In his own words, he wanted to know God's thoughts in mathematical form, but his quest to find this holy grail was unsuccessful. He could not achieve this greatest goal of his life. The arrogant and rebellious young man was gone, replaced by a wise, kind, and sympathetic figure who cared little for material possessions. Even his peers in the professional field held him in deep respect. He had become a legend in his own lifetime, but he never abused this privilege. On April 18, 1955, when he suffered an internal hemorrhage, doctors recommended surgery. But he took control of his life one last time and refused the offer with these words: "I want to go when I want. It is tasteless to prolong life artificially. I have done my share, it is time to go. I will do it elegantly." Even in that state, he asked for his glasses and papers in his hospital bed to continue his work. When he died at 1:15 a.m. the next morning, the unfinished equations he had been working on were by his bedside. The captivating magic of work had stayed with him until his very last breath. Einstein's legacy is not just one of equations and theories. He fundamentally changed our understanding of the universe, time, space, and reality itself. He taught us what gravity is, that time is relative, and that mass and energy are the same thing. He was not just a scientist, but a teacher, a philosopher who taught the whole world. His story has ended, but what we have learned from him and the inspiration he left us will never end. And let's conclude this chapter with his own words, his final lessons to humanity. Imagination is everything. It is the preview of life's coming attractions. Never give up on something you really want. A person with big dreams is more powerful than one with all the facts. A person who never made a mistake never tried anything new. Learn from yesterday, live for today, hope for tomorrow. The important thing is not to stop questioning. Friends, Albert Einstein's story ends here, but his influence never will. If you enjoyed this journey through his life, give the video a like, subscribe to Brutal History, and let me know in the comments. What do you think was Einstein's greatest contribution to humanity?